All right, let's jump right into this. Welcome to The Explainer. Today, we're taking a cinematic deep dive into the absolute marvel that is the human body. You know that old advice, right? Eat 5 or 6 small meals a day to keep your metabolism up, or skipping meals is dangerous? Well, today, we are totally debunking that myth, because biologically speaking, we are literally hardwired for cycles of feast and famine. It's how we evolved. But here's the real question. What actually happens, on a microscopic level, when the food stops? When does that incredibly beneficial fasting window cross the line into dangerous system-shutting starvation? Get ready because we're about to explore the biological clock. Picture this. A healthy adult takes their very last bite of a meal. The clock starts right now. Instantly, your digestive system is a bustling highway. Nutrients are flooding through the bloodstream, repairing muscle tissue, building brand new cells. All that extra glucose, it gets rapidly packed away into your liver and muscles as a storage fuel called glycogen. But as the hours tick by and that food fully leaves the stomach, this massive digestive machinery naturally slows to a halt. The fed state is officially over. We're now entering the fasting state. Which brings us to phase 1, the first 24 hours. Now this is where your biological machinery really has to pivot. As we cross that 8-hour mark, blood glucose levels naturally start to dip. To keep the brain and organs firing on all cylinders, your body starts raiding the liver and muscles for that stored glycogen. You can almost picture those energy stores slowly shrinking. Depending on how many carbs you usually eat, you could burn through this glycogen in as little as 8 hours, though for some it takes up to 24 or even 48 hours. But once that stomach is completely empty, a very specific, powerful signal gets sent straight to your brain. And that signal is ghrelin. Think of it as your body's built-in, glowing hunger alarm. It spikes automatically at the exact times you normally eat. Breakfast, lunch, dinner, bam, ghrelin spikes. And if you're running on a high-carb diet and aren't used to burning fat, this alarm rings incredibly loud. You get those intense hunger pangs. But here is the fascinating part. If you just ride out that craving, it doesn't last. The data shows this spike is remarkably short-lived. Within about 2 hours, those chemical signals just fade. They drop right back down to baseline, and your appetite vanishes with them. So, what happens next? Let's move into phase 2, switching fuel sources, covering the 24 to 72-hour window. With those short-term glucose reserves completely drained, your body shows off some serious metabolic magic. Zooming in to the microscopic level, your fat cells start breaking down triglycerides into glycerol and free fatty acids, dumping them straight into the bloodstream. Your body can use those fatty acids for immediate energy right then and there. Meanwhile, the glycerol gets shipped directly to the liver, and inside the liver, this brilliant transformation happens. It converts fatty acids into glowing ketone bodies. These ketones travel up to the brain, providing a super efficient, premium alternative fuel. So your body fat is actively melting away, but your vital systems, they're purring like a kitten. Now, what's really interesting here is a process called gluconeogenesis. See, your brain still needs just a tiny bit of actual glucose to function optimally. So the liver literally creates it from scratch, using non-carbohydrate sources like that glycerol we just talked about. This is a brilliant hack because it temporarily feeds the brain exactly what it needs without touching your precious muscle tissue. You might actually start to feel a little cold during this phase. Your body temp drops a bit since you aren't generating digestive heat, and your thyroid function slows down slightly. But make no mistake, your biology is working flawlessly. In fact, during these first few days, you enter what is essentially a biological superhuman state. Your body activates this hardcore anti-starvation defense. The breakdown of protein is substantially reduced to protect your muscles. Human growth hormone, or HGH, actually spikes. It acts like an invisible shield for your muscle tissue while simultaneously hitting the gas pedal on fat burning. So you're literally preserving your hard-earned muscle while selectively incinerating fat just to survive. It is incredibly efficient. And just how effective is this fat-burning state? Well, take a look at this staggering number. 382 days. That's how long a 27-year-old man in a famous medical study fasted. He dropped from 456 pounds all the way down to 180. That's roughly 3/4 of a pound of fat burned every single day. But, and I cannot stress this enough, you do not want to try this at home. Doing something like this is extremely risky and would literally kill an average person. This guy only survived because he had massive excess fat stores to run on, and he was under constant, strict medical supervision, taking very specific multivitamins and yeast to keep his systems from crashing. Without those exact conditions, prolonged fasting turns deadly real fast. Now, let's look at the absolute pinnacle of a healthy fast. Phase 3, the cellular cleanup and brain boost. This right here is where the magic happens. We're talking about a remarkable biological process called autophagy. Think of autophagy as your body's deeply efficient microscopic recycling plant. Your cells actively hunt down damaged proteins, old organelles, and dysfunctional junk cells, break them down, and use the scraps to build fresh, healthy tissue. This full system cleanup drastically lowers inflammation. It generates brand new, stronger white blood cells, totally rebooting your immune system. And you can even see it on the outside. It potentially slows down the formation of wrinkles, age spots, and clears up acne. It's basically cellular anti-aging. And while your body is cleaning house, something incredible is happening up in your brain. During this window, we see a massive spike in neurogenesis, literally the birth of new brain cells and neural connections. The brain ramps up production of a protein called BDNF, or brain-derived neurotrophic factor. I like to call BDNF miracle grow for your brain. The physical architecture of your mind becomes brighter, more efficient, and hyper-connected. We're talking vastly sharper focus, improved memory, elevated mood, and just an immense sense of mental clarity. But this is where our journey takes a very dark turn. Let's move to phase 4, crossing into starvation. So the crucial point we really need to understand is this 72-hour threshold. After about 3 days of zero food, for the average person, all those incredible superhuman benefits we just talked about, they come to a dead stop. Because fat stores are finite, right? And your brain's demand for glucose doesn't stop. So the body is eventually forced to find another fuel source. And it turns on itself. It begins aggressively eating away at your muscle protein to convert it into glucose. The line has officially been crossed. You're no longer fasting, you're starving. To put that danger into perspective, consider the tragic case of a slightly overweight man who attempted a 44-day water-only fast. By the end of it, he had lost 25% of his total body weight. Now, on paper, that sounds like a massive fat loss success, right? No way. Tragically, 2/3 of that entire weight loss was sheer muscle tissue. Because he didn't have the extreme fat reserves of the 382-day guy, his body had absolutely no choice but to literally eat its own muscle just to keep his brain alive. Which brings us to the inevitable next stage. Phase 5, system failure. As we track this prolonged starvation past the multi-week mark, the physical decline is devastating. The body is completely running on empty. Zero vitamins, zero minerals. That man who fasted for 44 days, he developed life-threatening deficiencies in thiamine, riboflavin, and vitamin K. Remember that incredible immune boost from earlier? Totally gone. The immune system completely crashes. Hair visibly thins out and falls out. Nails turn brittle, wounds just refuse to heal, and the person becomes incredibly weak and highly vulnerable to severe infections. But the most chilling biological reality is happening inside the skull. The brain, which is desperately starving for glucose, runs out of options. Gluconeogenesis from fat and muscle can only buy you so much time. When that runs out, the brain is forced to do the unthinkable. It starts metabolizing its own gray matter, just to keep the lights on. Visually, the actual volume of the brain shrinks. Neural activity just fades away, destroying concentration, erasing memory, and shutting down cognitive function. And the timeline ultimately reaches its devastating conclusion. With fat and muscle stores virtually exhausted and the brain feeding on its own tissue, the body enters extreme conservation mode. The heart, the kidneys, the liver, all these vital organs drastically slow down as the last bits of energy vanish. Now, science estimates some individuals might survive up to 2 months, depending on their starting body fat, but make no mistake, the biological cascade always ends in the exact same place. Progressive, fatal organ failure. Let's bring the energy back up and look at the big picture. Phase 6, fasting versus starvation. All right, let's step out of the dark for a second and objectively summarize this incredible biological journey. Picture a cinematic split screen. On one side, you have intermittent fasting done right, staying within that sweet spot of 16 to 72 hours. You see a vibrant, energetic person walking confidently into the sunlight. Inside, their body is an absolute powerhouse. Efficient fat burning, massive cellular repair, glowing healthy organs, and peak brain activity. But then look at the other side. The harrowing reality of prolonged starvation, passing that 72-hour mark. Rapid muscle wasting, severe nutrient deficiencies, a literal shrinking brain, and failing organs. It's the exact same underlying biological process, separated only by time and intention. Our bodies are truly masterpieces of evolutionary engineering.
They're brilliantly designed to heal, protect, and sustain us through cycles of feast and famine. But just like any ultra-high-performance machine, there are hard limits. We've seen how gracefully the human body switches fuel sources, cleans its own cells, and boosts its own brain power, but we've also seen the devastating, irreversible cost of pushing it too far into the starvation zone. So, knowing what you now know about this delicate internal biological clock, I want to leave you with this final thought to chew on. Where do you draw the line between optimizing your biology and breaking it? Thanks for joining me on this explainer, and I'll see you in the next one.